I'm now going to go through question 13 on exercise 9E, and this is a really nice problem solving question. A ball is released from rest at a point which is 10 metres above a wooden floor. Each time the ball strikes the floor, it rebounds with 3/4 of the speed which it strikes the floor. Find the greatest height above the floor reached by the ball the first time it rebounds from the floor. So let's just do a quick diagram of what's going on here. So this is exercise 9E, question 13. So what I've got is here my floor and the ball which is released from a height 10 metres above the floor. So here is 10 metres. And the ball is released from rest and it bounces, hits the floor and it rebounds up and then it must bounce again and so on. Now I've drawn these as if the ball is moving across. This would all be happening in one place, but obviously then I wouldn't be able to clearly see what I'm working out. And then it will carry on, but we're not really bothered about that. So I'm going to call this bounce 0 as such, so situation 0. This bit is all bounce 1 and this bit is all bounce 2 here. So it tells me that the speed that it hits the floor, it then rebounds with 3/4 of that speed. So what it's saying is, if it comes down here and hits there with velocity v0, then u1, the initial velocity of bounce 1, is equal to 3/4 of v0, the velocity that it hit the floor with. So u1, the velocity it leaves with bounce 1, is 3/4 of the velocity that it landed with from bounce 0. Now, it's asking me to find the height here of bounce 1, and I can't really do that until I know what the initial velocity is of bounce 1. And to be able to work out the initial velocity of bounce 1, I need to know the final velocity of bounce 0. So first, I need to consider bounce 0 to work out the final velocity of bounce 0. Now, in bounce 0, I'm going to write out what I know. I'm going to take downwards as positive. So S, the displacement of bounce 0, well, it starts here and it ends up down here. So its displacement is 10 metres. It's moved downwards 10 metres. The initial velocity is going to be 0 metres per second because the ball fell. I think did it say it fell? Yeah, it was released from rest. So either way, it's 0 metres per second is what it starts with. The final velocity, that's what I'm looking for. And the acceleration, well, we're talking about acceleration under gravity. It's moving downwards. I've taken downwards as positive, so it's going to be 9.8 metres per second squared. So I'm looking for V. I've got S, U, and A, so I'm going to use V squared equals U squared plus 2AS. So let's just sub in what we know. V squared is equal to 0 squared plus 2 times 9.8 times 10, which is 196. And so therefore V is equal to 14 metres per second. And I'm going to say V0, so the final velocity of bounce 0. We're talking about bounce 0 here. Now, what I just said was that the initial velocity of bounce 1 is 3/4 of the final velocity of bounce 0. So the initial velocity of bounce 1 is 3/4 of that 14. And that is 10.5 metres per second. And that bit's really important. So I've just worked out the initial velocity of bounce 1. And the question, part A, is asking me to find out the height reached in bounce 1. So it's this height here is what I'm trying to find out in part A. And I have enough information to be able to do that now. So let's have a look then at bounce 1. I'm going to again take, I'm going to take upwards as positive this time. It doesn't matter which one you take as positive as long as you are really clear about which one you're taking as positive. So upwards is going to be positive this time. S is what I'm trying to find out. Now I'm trying to find out the maximum height. So I'm not actually looking at the whole of bounce 1. I'm only looking at the start to the maximum point of bounce 1. This is the only bit I'm interested in now, halfway through bounce 1. S is what I'm trying to find out. I'm trying to find that displacement from the bottom up to the top of the bounce. U, I now know because we just worked that out. We said the initial velocity of bounce 1 is 10.5 meters per second, and that will be upwards. If you look at my diagram, it's quite clear the initial velocity is going to be upwards. The ball is travelling upwards. It's not somehow going down through the ground, it's bouncing up. It rebounded from the ground. So 10.5 meters per second. V, now at that maximum point, the velocity is going to be 0, and we've seen this a few times in different examples that we've done. At the maximum point of the bounce, that is when the velocity is going up, the ball upwards, 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 and then it changes to downwards, 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 downwards. So at that very instant, at the very top, the velocity of the particle or the ball is equal to 0. A is the acceleration, and again, we're talking about acceleration due to gravity. It's going to be 9.8, but it's going to be negative 9.8 because upwards here is positive, and we know acceleration due to gravity acts downwards. So negative 9.8 meters per second squared. T, I don't know, and I don't really care about. So I've got U, V, and A, and I'm looking for S. I'm going to again use V squared equals U squared plus 2AS. Now V squared here is 0, so it's equal to 10.5 squared plus 2 times negative 9.8 times S. And I can rearrange that. I will get that S is equal to 10.5 squared divided by 2 times 9.8. Just check. If you're not quite sure about what I've done there, you could do it a longer way than that and rearrange to find out what S is going to be equal to. And that gives me an answer of 5.6 meters. So I'm saying that the height of the first bounce of the ball is 5.6 meters. This height here is going to be 5.6 meters. Now, that is part A. Part B asks a very similar question, but it wants to know the height above the floor reached by the ball the second time it rebounds from the floor. So what we're looking for then is this height here, the second height, the height of the second bounce. Just like before, I couldn't start working out anything to do with bounce 1 until I worked out the final velocity of bounce 0, because I needed the final velocity of bounce 0 to know the initial velocity of bounce 1. Well, similarly, this time, the initial velocity of bounce 2 is also going to be equal to 3/4 of the final velocity of bounce 1. We were told that in the question, that it rebounds with 3/4 of the velocity that it hit the ground with. So I need to work out the final velocity of bounce 1 before I can start working on bounce 2. This one's an interesting one because actually the final velocity of bounce 1 will, because this is symmetrical, it will be equal to the initial velocity of bounce 1. So I could skip straight to my answer. I could say, well, the final velocity of bounce 1 will be 10.5. Because this bounce is symmetrical, we're not considering air resistance here. In real life, that would never happen. But in this case, it would be 10.5. However, let's pretend we don't know that for definite. We're going to prove it to ourselves. So we're going to look at bounce 1. So remember, my aim here is to be working out what the final velocity of bounce 1 is. That's what I'm looking for. So in bounce 1, let's write out what we know. Oh, I don't even remember the sumat letters. I'm looking at the whole of bounce 1 here. So I'm not just looking at the first half like we did last time. I'm looking at the whole thing. And I'm going to take downwards as being positive. Now, in the whole of bounce 1, S is going to be equal to 0 meters because bounce 1 started at the floor, it went up and landed again at the floor. So it's still 0 meters, the displacement. U, we know, was 10.5, but it's 10.5 upwards, so it's therefore negative 10.5 meters per second. V is what I'm after. A is going to be 9.8 meters per second squared. Acceleration due to gravity, and I've taken downwards as positive, so it's going to be a positive number. U was negative because that U is upwards, and I care about downwards being positive. So I want to find out what V is. So I know V squared equals U squared plus 2AS. If I sub in then for what I know that V squared is equal to U is negative 10.5 squared. Well, S is 0, so that bit disappears. So straight away I can say that V is going to be equal to 10.5 meters per second. So that is the same as what U was, although obviously in the opposite direction. But I've done it using that. We could have skipped straight to that answer if we wanted to. So the final velocity of bounce 1 is 10.5 meters per second. So again, let's use what we said at the start, U2, the initial velocity of bounce 2 is 3/4 of the final velocity of bounce 1. So it's 3/4 of 10.5. Type that in and I should get an answer of 7.875 meters per second. So I know that my initial velocity of bounce 2, oh, I've skipped off that bit there, is 7.875. So let's focus now on just bounce 2. And remember, what we're aiming to work out is the maximum height of bounce 2. So all I'm looking at is the very start of bounce 2 to the middle section, to when the ball reaches the maximum height, just like I did for bounce 1 in part A. I'm only caring about this first part of bounce 2. So I've got, what do I know? S, U, V, A and T. And I'm going to take upwards as positive this time. Well, S is what I'm after. I want to know that maximum height of bounce 2. U, we've just worked out, it was 7.875. Oh, 7.875 meters per second. And it will be upwards. You can tell that easily from looking at the diagram. The velocity at the start is going to be upwards. The ball's not going through the floor, it's bouncing upwards. V is 0. We said last time at the maximum height, the velocity is going to be 0. A is going to be negative 9.8 meters per second. Acceleration, meters per second squared, sorry. Acceleration due to gravity, but that acts downwards, and I'm taking positive as being upwards, so it must be negative. Time, don't know, don't care about. So V squared equals U squared plus 2AS. And I care about S, so S is equal to V squared minus U squared over 2A. And if I type in my numbers there, then V squared is 0, so it doesn't really matter. Minus 7.875 squared, that's what I got for U, over 2 lots of negative 9.8. And therefore my answer that I get is going to be equal to, if you type that in on your calculator, you should get 3.2 meters. So the height of the second bounce is 3.2 meters. And I could write S2, just to be clear there, I'm talking about the height of the second bounce, 3.2.